This lesson is on compound events. A compound event consists of two or more events, such as you roll a die, then you toss a coin, or rolling a die, then rolling a coin, rolling it again, or tossing a coin, then tossing it again. Are these compound? What about rolling a die? That would be no, because rolling a die is just one thing, okay? No. If you roll a die, then choose a card. Yes, because that's two things. Toss two coins at the same time. No, because that's just one event. Tossing two coins at one time is just one event. Tossing one coin, then tossing another. Yes, two events. What is the sample space for tossing a coin? You know that. It's heads or tails. What is the sample space for tossing a coin the second time? Well, it's the same thing. It's heads or tails. This is known as independent event because the sample spaces are the same for each one of them. Let me repeat it. A sample space, when the sample spaces are the same for each event, those events are known as independent. If I have a pair of blue socks, a pair of black socks, a pair of gray socks, and two pair of brown, what is the sample space if I want to know the probability of choosing a pair of black socks? Well, you know that you would just list them all. Blue, black, gray, brown, and brown. If I choose a blue pair and do not put them back, what is the sample space for choosing a pair of black socks? Well, if I choose a blue pair and I don't put them back, then the blue pair won't be there the second time. So I'll just have black, gray, brown, and brown to choose from. Well, this is known as a dependent event because the sample spaces are different. The first time we had blue, black, gray, brown, brown. The second time we just had black, gray, brown, and brown. Once again, these are dependent events because the second one depended upon what happened on the first time. If I have a pair of blue socks, same thing, a pair of black, a pair of gray, and two pair of brown, what is the sample space if I want to know the probability of choosing a pair of black socks? We've already done that. If I choose a pair of blue and put them back, what is the sample space for choosing a pair of black socks? Well, if I choose a pair of blue socks, got those, but then I put them back, then the same thing appears the second time, doesn't it? That makes these independent events because the sample spaces are the same both times. So if you choose something and put it back, that makes it independent. If you choose something and you don't put it back, that makes it dependent. From a deck of 52 cards, how many items are in the sample space for choosing a king of hearts? Well, if it's a deck of 52 cards, then you have 52 choices. So there would be 52 items in the sample space. If I choose a card and do not put it back, how many items are now in the sample space? Well, that would be 51. So these are dependent events. All right, from a deck of 52 cards, how many items are in the sample space? 52. If I choose a card and put it back, how many items are now in the sample space? Well, there'd still be 52 because you put the card back. And this would be an independent event. Independent events, if the occurrence of one event does not affect the probability of the occurrence of the other. Independent event, if the occurrence of one event does not affect the probability of the occurrence of the other. A dependent event, if the occurrence of one event affects the probability of the occurrence of the other. So a dependent event, the sample space will be different the second time than it was the first time. To find the probability of an independent compound events, you multiply the probability of each event. So this is read as the probability of A, then B, is equal to the probability of A times the probability of B. So you toss a coin 2 times. What's the probability that you will get a heads on both tosses? So we want to know the probability of heads, then heads. That would be equal to, what's the probability of heads on the first time? 1 out of 2. And on the second time, it's still 1 out of 2. So the probability of getting a heads would be 1 times 1. On both times would be 1 out of 4. You roll a number cube twice. Remember, a number cube has 1, 2, 3, 4, 5, and 6. And then you're going to do it twice. So find the probability of 1, then 2. Well, the probability of a 1 on the first time is 1 out of 6. The second time it doesn't change because those numbers are still there on the number cube. So the second time it will be 1 out of 6 for a 2. That gives you 1 out of 36. All right, probability of a number less than 4, 1, 2, or 3. So that would be 3 out of 6, or 1 out of 2, times the probability of a 1 is 1 out of 6. So that gives us 1 out of 12. All right, the probability of a number divisible by 2. Let's write them out here. 1, 2, 3, 4, 5, 6. That's our sample space. The numbers that are divisible by 2. 1, 2, 3. So we've got divisible by 2. There are 1 out of 2, and then a 5 would be 1 out of 6. So once again, that'll be 1 out of 12. All right, the probability of a 3. Probability of a 3. There is only 1 3. 1 out of 6 times odd number. 1, 2, 3 times 1 out of 2, because 3 out of 6, that's 1 out of 12 again. All right, the probability of odd, then even. Well, there are 3 odd numbers and 3 even numbers. So 3 out of 6 would be 1 out of 2, and 3 out of 6 would be 1 out of 2, so you would get 1 out of 4. All right, it's your turn. An arrangement of 8 students is shown at the right. The numbers on all the students are in a basket, and the teacher selects a number and replaces it. That makes this an independent event. Then the teacher selects a second number. Find each probability. Probability of student 1, then student 8. Probability of a student in row A, and then a student in row B. The probability of a student in row A, and then student 6, 7, or 8. Okay, your turn. Pause the video and come back to me. All right, the probability of student 1 would be 1 out of 8. And the probability of student 8 would be 1 out of 8. So that would be 1 out of 64. The probability of student in row A would be 1, 2, 3, 4 out of 8, or 1 out of 2. And then a student in row B would be 4 out of 8, or 1 out of 2, would give us 1 out of 4. And the probability of a student in row A is 1 out of 2. And then student 6, 7, or 8, well, that's 3 students out of 8, which gives us 3 out of 16. Did you get all 3 of those? All right. To find the probability of dependent events, multiply the probability of the first event by the probability of the second event after the first event has occurred. So that's how this second this reads down here. The probability of A, then B, is equal to the probability of A times the probability of B after you've already done A. You'll see it. You select a card at random from those below in that wonderful word, mathematics. The card has the letter M. Without replacing the M card, you select a second card. Find the probability that you select a card with the letter A after you select the M. Alright, so let's look at this. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. Okay, so it says the card has the letter M. So that means you selected that M. Without replacing it, you select a second card. Well, now there are only 10 items because you've taken out an M. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the probability that you select a card with the letter A after you select the letter M. So there's 1, 2. There's 2 letters that have an A, so that would be 1/5. So the first time the probability was 1, 2 out of 11. And then after you take the M out, your probability of getting an A is 1 out of 5. So you go 2 over 11 times 1 over 5, and that gives you 2 out of 55. But you see how this changed? The bottom number changed because that's a dependent event. In a dependent event, the sample space is going to change on the second time, okay? Alright, what's the probability of selecting an M, then without replacing it, selecting another M? Well, the first time was 2 out of 11. We established that already. Alright, the second time, we've taken an M out. Now there are 10 items left, and there is only 1 M. So we multiply those two together, and we get 2 out of 110, and then we can make that 1 over 55. The other way to do that is come over here. It's 2 out of 11 times 1 out of 10. 2 goes into 2 one time. 2 goes into 10 5 times. 1 times 1 is 1. 11 times 5 is 55. Alright, your turn. What's the probability of selecting an H on the first try, and then without replacing, selecting an H on the second try? Pause the video and then come back to me. Okay, so the first time, remember we've got 11 letters. How many H's do we have? 1. Times, the second time we've only got 10. And how many H's do you have? 0. So that gives us 0 out of 110, which is equal to 0. So the probability of getting an H both times is an impossibility. What is the probability of selecting an H on the first try, and then after replacing it, selecting an H on the second try? Well, after replacing it tells you that it's what kind of event? Right, it's an independent event if you replace it. So the first time it's 1 out of 11. The second time it would be 1 out of 11. So that gives us 1 out of 121. Alright, 2 coins are dropped at random onto the surface below. What is the theoretical probability that both coins fall into the shaded area? Well, there are 1, 2, 3 by 1, 2, 3, 4, 5 blocks. So that's 15 blocks. And there are 5 shaded ones. So that's equal to 1 out of 3. So the first time you drop a coin, it's 1 out of 3. The second time you drop the coin, it's 1 out of 3. Because both times there's going to be 5 shaded areas. It doesn't matter where the first coin lands. So that gives you 1 out of 9. Now I think you'll probably do well with your work. Have fun.